Line L is the bisector of an angle A and B is any point on the line L. BP and BQ are perpendiculars from B to the arms of angle A. Show that triangle APB is congruent to triangle AQB and BP is equal to BQ, or B is equidistant from the arms of angle A, which means that the distance from the two arms to the point B is the same. Welcome to Math-o-tropism. So the first step is understanding what is given and identifying the concept. We have been given a line L is the bisector of an angle A, which means it cuts the angle A into two equal halves. So if it is cutting the angle A into two equal halves, it means that angle ABAP will be equal to angle BAQ, and both will be half of the total angle QAP, that is angle A. They have also given that BP and BQ are the perpendiculars from B to the arms of angle A, which means that AP and AQ are the arms, which also means that perpendiculars means 90 degrees. So angle APB is equal to angle AQB, which are both equal to 90 degree. We need to show that triangle APB is congruent to triangle AQB and also BP is equal to BQ. That means the distance of the point B from both the arms AP and AQ are the same. So we will be first considering the triangles APB and triangle ABQ. We can see that from step 1 we already have angle BAP is equal to angle BAQ and angle APB is equal to angle AQB, which is 90 degree. And when we see the side AB, it is common to both the triangles. Now we have two angles to be equal and one side to be equal, and this side is not the included side. So when we think about the congruency rules, we can see that the two angles and the side which are not included are equal, means we can show that the two triangles are congruent by the AAS congruency rule. So therefore we will be using that. So by AAS congruency rule, we have triangle APB. When we see angle A is equal to angle A, angle P is equal to angle Q, which is 90 degrees. So the balance remaining B is the corresponding vertex in both the triangles. So therefore triangle APB is congruent to triangle AQB, and once we have proven that both are congruent, then by CPCT, that is the corresponding paths of congruent triangles, we can prove that the first two sides taken at a time AP will be equal to AQ and the second two taken at a time PB will be equal to QB, which is nothing but BP equal to BQ, which is asked. So thus we have shown that we can prove that these two triangles are congruent. So the next step is forming equations and solving the sum. We have been given a line L is the bisector of angle A, which means that the angle BAP is equal to angle BAQ, which is half of angle A. We'll keep as equation 1. Then BP and BQ are perpendiculars from B to the arms of A. That means angle BPQ and angle BQA both are 90 degrees. So let us keep it as an equation 2. We need to show that the triangle APB is congruent to triangle AQB and BP is equal to BQ. So for solution, we will first take these two triangles which have been asked to prove that they are congruent. So triangle APB and ABQ we will take. From 1 we have that angle BAP is equal to angle BAQ in both the triangles, corresponding angles, and from 2 we have that angle APB is equal to angle AQB, which is equal to 90 degree. So AB is equal to AB, which is both common in the triangles. So as a result, by AAS congruency rule, my triangle APB is congruent to triangle AQB, and by CPCT, that is the corresponding parts of congruent triangles, we have BP is equal to BQ, that is B is equidistant from the arms of angle A, thus shown. Thank you.